Hi friends, in this video we are going to see about knapsack problem, and it comes under brute force algorithm. Same thing will comes under some other algorithm also. This brute force algorithm is a straightforward approach. Now we are solving this knapsack problem directly, and it comes under unit 2, and it is in this course design and analysis of algorithm. So knapsack problem, here we have n items and it consists of weights that will be mentioned with W, and value for the particular weight it is mentioned with V, and the maximum capacity to hold or taken is knapsack of capacity, it is mentioned with W, capital W, and we have supposed to check how many items, what are the valuable items we can take with capacity. So this is what the constraint is, the problem is. Here we have a bag which is can able to hold 15 kgs, and we have values like 12 kg and it is of $4, 1 kg it is of $1, and 4 kg it is of $10, and 1 kg with $1 and 2 kg with $2. So this is what the combination is given, and what are the combinations we can take. For example, 1 and 1 we can, if for example this $2 and $1 if we take, it will have two values, that is 2 kg weight, and we will have 3 values. So this is what they ask, like this we are supposed to calculate. Directly we will go into the sum. For example, here it is a one person taking the weight, and it checks for how many weights we can take. So this is what example. So here it is an example program, example problem for knapsack algorithm. Here it is total capacity is 10, and for item 1 we have weight of 7 and value for it is 42, and for weight 2, item 2 weight is 3 and value is 12, and item 3 the value is 40 and weight is 4, and for fourth item value is 25 and weight is 5. So this is what the problem is given. So now we are considering, initially we don't have any weight, and so we don't have any value into that bag. So the main motto is to take the weight which is lesser or equal to the maximum capacity of knapsack, that is 10, and the value should be higher. So initially I am taking we don't have any weights, data item there, so we don't have any value. So if I take one element, then it is 7 and 42. Second element alone 3 and 12. Weight is 3 and value is 12. So third, in the same fashion, the single elements are given. So now we are going for combination. If I take first element and second element, if I take first element and third element, if I take first element and fourth element, so the weight of both the first element and second element is calculated, and the value is also calculated. So in the 1,2 element, so the weight is 10 and the value is 54. For 1 and third element, the weight is 11, so it exceeds the knapsack problem. So we are supposed to mention not feasible as an answer. We can't able to take those two combinations. So for 1,4 also it is 12, it is not feasible. So 2,3 it is 7, weight is 7 and the value is 52, and 2,4 is weight is 8 and the value is 37, and 3,4 is 9 and the value is 65. So the two combinations are over, then we are moving to three combinations. So 1, 2, 3 is taken, weight is 14. So in the same fashion, the third three combinations are taken. So in the next value 2, 3, 4, next is it is of 12, and the next value is 1, 2, 4, it is of 15, and the next is 1, 3, 4 and value is 16. So all these four values are greater than the knapsack capacity, that is above 10. So we are not this is not feasible for taking the consideration. The last is three combinations. After three combination we are going for four combination. If I take all the weights, then the weight is 10 and it is weight is greater than 10 and it is not feasible. So 7 plus 3 10 and 4 plus 5 9, totally 19 elements was there. So it is not 19 weight was there, it is not feasible. So consider we are limiting the not feasible solutions. The among the feasible total values we are checking which value have the highest value. So here we have 65 as the highest value. So the combination for this is 4 comma 3. So we are taking the fourth item and third item into the knapsack problem, and the weight of total value of it is 65. And for this problem, problem size is total number of items. We have four items, so it is 4. Basic operation is we are comparing, so this is what your basic operations. And operation count is we are comparing and adding and comparing with the possible items. So number of sets we have is 2 power n. So these are the possible subsets we can go with knapsack problem. Thank you.